Ojas Aerospace operates across two operational extremes. On one side, high-speed drones execute precision agricultural spraying. On the other, rural kiosk operators log transactions in remote villages. To function, these two realities must merge into a single network node. Managing this scale requires a system capable of tracking millions of regional sales leads while simultaneously monitoring the telemetry of thousands of autonomous drones. Standard off-the-shelf ERP systems struggle with this duality because they are typically optimized for either digital supply chains or physical manufacturing, rarely a hybrid of both. This requires a bespoke System Requirement Specification, or SRS, engineered from the ground up to handle both domains. This SRS maps algorithmic execution, like drone flight telemetry, and human-centric workflows, like sales outreach, into a unified data schema. To understand this architecture, we must look at how the system builds from the ground up, starting with standardized human tasks, moving into cognitive sales processing, culminating in a cyber-physical command center. Unifying these domains under a single architectural framework prevents the data fragmentation that occurs when high-tech assets and human workforces operate in separate silos. The foundation of the Ojas ERP is a rigid work breakdown structure, or WBS. The system divides operations into high-level projects, from marketing to R&D. Each project cascades out into 2 to 10 specific activities. These are governed by a mathematical rule. Every activity breaks down into exactly 10 standardized tasks. This structural rigidity ensures that data ingestion is uniform. Whether the task is software development or local procurement, the system tracks the progress through identical 10-tier lists. This feeds the performance module, which anchors an individual's daily planning and KPIs to the completion of these specific task nodes. The performance module also captures qualitative variables, using mood trackers and persona identifiers to monitor the emotional state of the distributed workforce. By standardizing both objective task completion and subjective mood data, the system converts human labor into predictable, optimized operational inputs. The black hat filter then identifies operational risks and constraints. Finally, the green hat filter uses these to generate creative solution packages, like pairing drones with satellite monitoring. This process results in an objective CRM classification, labeling the lead as verified, unverified, potential, or junk. Passing organic sales psychology through these standardized cognitive filters provides a consistent analytical baseline, aligning a salesperson's intuition with the enterprise's actual systemic capabilities. Moving from the human layer to the hardware layer, the asset management module tracks the physical nodes of the enterprise. The ERP categorizes physical assets, including digital kiosks, CCTV networks, and autonomous drones, as active corporate nodes, subjecting hardware to the same reporting protocols as human employees. Drones act as streaming telemetry nodes, transmitting real-time data on flight hours, battery health, and GPS coordinates directly to the ERP. Similarly, digital kiosks stream connectivity status, operational uptime, and power consumption data. The CCTV system provides its own data layer, tracking camera status, access logs, and storage availability. This telemetry allows predictive maintenance algorithms to monitor asset health and identify potential hardware failures before they occur. Because hardware is integrated directly into the ERP, a low battery reading on a drone can automatically trigger a WBS task for the IT support department, initiating a human workflow without manual reporting. Expanding from individual assets reveals the full scale of the interconnected enterprise system. A system of this complexity requires a strict role-based access control, or RBAC hierarchy, to maintain security and data integrity. At the pyramid's base, local operators have localized permissions. The middle tier, district officers, manages regional fleets, restricted to specific areas. At the apex, the super admin has total visibility across all departments and physical establishments. This strict hierarchy allows Ojas to scale while ensuring that sensitive customer profiles and critical aerospace hardware are accessible only to authorized personnel. This architectural structure culminates in the ICT dashboard, the primary interface for real-time monitoring. The dashboard consolidates different realities into one view, placing a drone battery warning immediately alongside our regional sales achievement notification. The custom SRS effectively translates mechanical telemetry and human behavior into a singular data stream. By structuring human behavior into algorithms and treating machines as active corporate nodes, Ojas manages its global workforce and aerospace hardware from one integrated interface.